Hey guys, how's everything going? This is Jaser. This is another episode of React series videos. What a journey! It's already come to 19th episode. Wow. Okay. Well, today I'm going to talk about how React scheduler works. Don't be scared. It's really not complicated. I thought it was pretty complicated, but after I tried to read through the code, it's actually pretty straightforward. I've already put up the materials in the post on jaser.dev, so if you prefer reading the text, reading rather than listen to me speaking, you can go jaser.dev, and I'll just explain the things based on this post. And yeah, let's begin. So don't worry about the scheduler first. Let's take a look at one piece of code we've already covered in previous videos. On the very first episode, we've already covered it. So in React, it breaks up. Let's recall that React has holds fiber tree, which is the node. You can call it virtual DOM, but yeah, we should stop calling that now. Just the fiber tree containing all those fiber nodes. And when an event happens, any message comes, React needs to update it, right? The naive approach would say, okay, from the root to the leaf nodes, just update each of them. And the update of each node is this perform unit of work. It's called some work. Yeah, it got some work to do. And then perform unit of work is for each fiber. And then because we have a big tree, I've already covered this in the previous post called about the traversal algorithm. A work progress here is just a global state to hold the position. You can think of like a small man walking on a tree, or you can call it a visitor in those tree traversal algorithm. Just some cursor. It's just some position. This is for works loop sync. This means that you see that code here, while it's not now, we just continue to perform the work. So this won't be interrupted. That's why it's loop sync. Why it's called work loop, we will cover it later. But you notice that it's sync. But in concurrent mode, the next version of React is about, it's a bit different. So you see, work loop is the same. This is how they do the job, but it's not sync anymore. It's concurrent. But while loop, they're the same, but except that it has a check called should yield. Yield means surrender, just to hand out the control to the main thread. And generally means that if you need to render something, you do it and then come back to me later. So this is how the concurrent mode should be understood. It just try to update a node, and then conceptually it just say, okay, whatever is done, you do some more high priority work, and I'll continue. So rather than traverse through the whole tree, now just traverse one, break, okay, and then traverse another one, break. This is interruption and resume, and this one, should yield is paid as the important part. So this leads us to the concept of a scheduler, because for the reconciliation, it doesn't have this concept of which is priority or not, right? Someone needs to tell me that should I yield or not. If I need that someone, that's the scheduler. Before we jump straight into the scheduler, let's start with some background knowledge. First one is event loop. Oh man, this is like a useless piece of information, knowledge in daily work, but useful knowledge when you are in some job interview. I think this is like someone really wants to crack you down by asking this question. But to be honest, I'm never able to explain it very well. Every time when I want to explain it, I felt like it's super hard to explain. So I just suggest you watch this videos from Jake Archibald. He has done a very good job, and in that video you will see why it is called event loop. So I'll just summarize here. So you can think of any task like user input event, network event, anything is called event, and then you need to do something. That something is task. It's a macro task. It's in a queue, no matter what the queue is, but it's just some queue, yeah. And then the event loop is just say, okay, if there's a task, I'll grab it and run it, and then the task might schedule other some micro task which must be run before you surrender, before you yield to the main thread. That's called micro tasks. And then when this gone, I'll just the event loop will surrender to the browser engine, the main thread, say, okay, you're ready to do some rendering, and browser do that, and then you'll come back to this task again. So this is called event loop. You can see that it's kind of like okay, there are some tasks in a group, and someone is outside the room and say, okay, you next one, and they go, next one comes, oh, doctor, yeah, someone waiting to see the doctor. The doctor say, hey, the next one will come here, and then he just the doctor will see his or her problem and get it fixed, and then he will do what? He will just have some cup of tea, right? Just drink some water, and then okay, next one, and next one will come into the room. So this is what? This is a loop. This is a loop about events, so it's called event loop. But in React, it's kind of like similar, right? We've divided the work into a list of unit work, and list is not a tree. It's like a linked list. It's linear. It's just a flat list. Just to refer to my previous post about the Travis algorithm. Yeah. Also it does the same. Okay, we finished this work. Okay, grab a yield. Try to yield. Grab a cup of coffee, and then say next piece of work. So this is why it's called a work loop. Okay, cool. Event loop. Watch the video. The next one is set immediate. This is really interesting. Set immediate is to schedule a new task without blocking the rendering. We already know the trick, right? If you try something, if you have seen some web page jagging, just freezing, if you do something, remember, this is, I've already know this when I started to do this programming of JavaScript. It's like set timeout, right? So just do some timeout 0. Okay, there's a typo here. You should say timeout function, but yeah, you know what I mean. Do some anything wrong, set timeout 0. Why it works? Because when set timeout is called, it will actually schedule the task in a macro task queue, but it's not directly in the task queue. It will schedule it with a timer API, which is not the part of the JavaScript, but timer of the host. This timeout system is the host API. So actually, when you run set timeout 0, it doesn't necessarily mean the task will be run after 0 second or any time. It will say, okay, set it, and when it is ready, it will insert the task into the queue. So this is not actually very accurate. It's just the minimum, I would say. It will schedule macro task. But there's even more bad. If battery API is called set immediate, why set immediate is better than set timeout? It's because the set timeout might be nested, right? Set timeout, and then the function is set timeout and set timeout. And nowadays, the browsers basically have minimum of 4 milliseconds in a nest call. So even if you set 0, it won't be 0 actually, except the set immediate API. It will set the schedule the task right away without this timeout. The timeout is some host API. And set immediate, it doesn't have that delay, but it's only available in IE and Node.js, so it's not actually workable in Chrome or something. So this leads us to this piece of code in Scheduler, which is pretty easy to understand. You see, he said schedule perform work until deadline. You don't need to worry about the name here. You can see the if-else branches. He says if there's local set immediate, which means the set immediate we're talking about, then this is schedule perform. This function is a wrapper of perform work until deadline with local set immediate. If not, it will use the message channel. I think I've covered the message channel before. It's better than the set timeout. And then if message channel is not working, it will fall back to local set timeout. So this is just a wrapper on the perform work until deadline this function with these fallbacks of message channel and set timeout. Yeah, all of this is just to schedule a new task without blocking the rendering. This is pretty cool. And then the third piece of this priority queue, this is very common data structure, even if your daily life, not maybe daily, but in your job interview, I think it's pretty important. You can, here is a link on BFE. You can just try to create a priority queue in JavaScript by yourself. Anyway, it's pretty straightforward. And why I mention this is that actually in React Scheduler, priority queue is used with the implementation of MinHip. And the source code is there. You can get a look. But remember, priority queue. We're doing a priority, right? The concurrent element is all about priority. If the high priority task is there, we run the high priority ones first. So priority queue is a natural approach to store those tasks. Okay, so yeah, next one is we need to see the work loop concurrent, which the piece of code we see here, work loop current. We take a look how it is called in our in React. I draw a diagram about the functions which leads to work with this function call. The source code is all in this React Fiber work loop old.js. You can refer there. Let's break it down. So all starts from this ensure route is scheduled. I've already covered this in this previous videos. Every time it's just basically means that, okay, just to try to re-render the whole route. Of course, there's some performance optimization, so it doesn't necessarily run updates on each fiber, but basically the concept is the same. So ensure route is scheduled to be re-rendered, to be updated. And in this function, I put it under it. It calls scheduler callback with priority. Okay, this is the part where priority comes in. And the next one is callback. I didn't use the arrow here because this perform concurrent work route on route is callback. Obviously, there must be perform sync work on route or something. Okay, so this is callback. When schedule callback, it's a schedule, right? It means that this callback is not run immediately. It will be scheduled by scheduler. Okay, so the callback is perform concurrent work on route, and you will call render routes concurrent. We'll skip the details, and you will go to work loop concurrent, which is this piece of code. Work loop concurrent, and in it, it will check if we should yield or not. If we should not yield, we will continue performing the unit of work, and then we check if there's more work to work on. It will check should we yield, and then just like here's already a loop, right? We just do this over and over again. But if it is should yield, it will return loop incomplete, which will result in perform concurrent. Okay, I think there's a mistake here. Oh yeah, I noticed that there's a here, but I will not stop this video. Just please stay with me. I will update this piece of image. So if we should yield, it means that route is incomplete, and it actually returns return itself, the closure of itself as a return value. But if there's the whole tree is reconciliated, then reconciled, and then it will return route complete, and this callback will return now. Okay, there is a mistake here. It should be swapped. Anyway, so that's it. This is the piece of very important information. Perform concurrent work on route returns a closure of itself if interrupted. Why it returns a closure of itself? Yeah, you've already seen it. When it's interrupted, we need a way to resume it, right? But how can we know it should resume or not? For scheduler, because scheduler doesn't know the details of each callback, we need the mechanism. We'll cover it later soon about this topic, but just notice that for this work, for this callback, if you doesn't need to do anything more, you just return nothing. If you return a function, the scheduler will treat it as next step to do. Say, okay, I'll schedule a new task to run it for you for continuation. Well, this is very important. Okay, finally, we come to scheduler. Schedule callback. Schedule tasks by expiration time. Okay, there's a typo here. I need to fix it. So, sorry about that. Okay. So scheduler is like you can see assistant in doctor room. Say he needs to know what kind of tasks there are, what kind of patients there are, right? You need to prioritize with their severity. Like, okay, someone needs to be treated right away. He needs a way to prioritize them, which is the priority queue. So what is the priority actually? Yeah, you've seen it. This is the piece of code. You can see that actually React, the scheduler does this by using expiration time. Yeah, here it is. Expiration time. First we start with start time, current time plus delay, start time, and then depending on the task priority, it will add some timeout. Here it is. Obviously, if the higher the priority is, the shorter timeout it is. Like immediately it will use a negative number, meaning it's already timeout before it's begin. And for this is normal. So you can see normal priority tasks have like 5-second timeout, and this one is user blocking for randomly input stuff 200, and this low priority 10 seconds, and this one is never times out. So it has possibility that this kind of task will be never run. Okay, so based on different priorities, we have different timeout plus the start time. We have this expiration time, right? Expiration time meaning when this task should be expired, it be timeout, and then these priority queue will choose the task with the soonest expiration time. And this is it. It's pretty simple, pretty natural, right? Say if you want to do something out of some task, you definitely choose something that needs to handle right away because it expires soon, right? Sooner than you handle it sooner. So this is it. The code is very straightforward. And after creating the expiration, the new task is created, and you can see here. This is delay task. We'll cover it later. And if it's not delay task, a delay task means something like a schedule, but with some delay, like say timeout stuff. We take a look at this non-delayed task. It will push the task queue. Task queue is a priority queue. You can think of it like array here, but internally it does not. It has some min heap algorithm there. Anyway, it will push the new task in, and also it just requests a host callback, flush work. So this is there are two pieces, as I said. One, push into the task, just pretty straightforward. The next one is request callback flush work, meaning process them. This is actually say the assistant say, hey, okay, this patient, you go to the queue, and then the assistant will tell the doctor, say, okay, just to treat the first patient. This flush work, meaning, yeah, treat them. Request callback is necessary because scheduler doesn't know the host information, so this one could be configured to any kind of API, so it will be requested. So flush work meaning process the task and request host callback. We will see what it is by looking at this piece of code. You can see request hosted callback. It will set the callback to the scheduled host callback, and then it will schedule perform work until deadline. We've already seen it. This is just a wrapper of the this one. So schedule callback here. Yeah. Schedule perform work until deadline. Yeah. So it actually will be just it will set a immediate task without blocking the main thread, and this function will be called. Okay, yeah, now you can see that it will get the callback right away. If it is not now, it will start working on it. Basically, scheduled callback is the flash of work. Remember, flash of work. It will call it, and with a tag saying, okay, do you have time left? The time has left is hard coded to true right now. Why? I don't know. It's hard coded. Maybe it's because of some refactoring. Before it was some other logic, but now after refactoring, it was set to true. But anyway, it doesn't affect us. So the flash of work is run. You can see that there's the return value it says has more work or not. If this has more work, it will continuing run a task like a loop, right? Can schedule perform until deadline. It will run itself again, but with this set immediate. Schedule host callback is the flash work. So let's see what's in the flash work. It's return a work loop. So this work loop is the core of scheduler. We've already seen the work loop in the reconciliation, work loop concurrent, work loop sync, and now we have work loop in the scheduler. So they work basically the similar. Let's take a look at the work loop. It says, okay, if the current task is not, okay, this one, expiration is bigger than the current, it's not expired, but we should yield, right? We should check the yield. Every time we do some loop, we need to check yield. This is the same as the should yield method. We will cover it later to see the how it works actually. But here you say, okay, if you should yield, then we should stop. Because if you stop, the task actually will not be popped. It will be scheduled somewhere again. Okay. Just as, yeah, you see here, we'll cover it later. And then the callback is current callback. Now, remember what is callback? Yeah, callback is this one. This one is a task. Schedule a task. This one, perform concurrent work on root, is the callback of that task here. So, stay with me. Yeah, the callback is function. And did user callback timeout? Yeah, expiration time comes into play. If it is smaller or equal to current time, then it means what? It is already timeout. You say callback, perform concurrent work on root will be called with this flag whether timeout or not. And remember, we've emphasized that the return value differs based on whether it is interrupted or not. You can see continuation callback. If return a function, then the current task, the callback will be updated with this continuation. But if it is not a function, it means that the task is done. And you can see the task is popped. So this is why this is called continuation. For a task, if you haven't finished, you just return a continuation callback. I will update it into the first in the task, and then I will process it later without forgetting about you. So that's it. Advanced timers is about delay task. We'll cover it later. And yeah, if some other task, we just pop it because we don't need the callback. Pretty straightforward, right? Here, if there is whether it has time or not, we can take a look at the perform concurrent work on root. It takes a parameter. Oh yeah, it takes an argument about the flag, and inside of it, you can see there's some logic there. If they said should time slice mean if this is true, some lanes, we will cover this in the future episode. You can ignore now, but it will say it did not time out. Yeah, if the timeout is disabled or if it is not timeout, this is the flag is actually this one. So if it is already timeout, you should say we should not use time slice, means we should not use concurrent mode. And it will do what? It will render the root sync without yield, you can see. So for the rendering a whole tree, if we don't have, if you already time out, say, okay, you cannot wait anymore, then we will render root sync. If we still have time, we will render it with root concurrent, in which you would check if you should yield. Okay, go back to our work loop. Yeah, this is why. Yeah, I said if we return the value of this callback this function, it means the task is not done. We should work on it again. Cool. Yeah. So how exactly should yield work? This is pretty interesting piece of code, and the comment itself is actually explains everything. For enable is input pending, we can ignore it for now. I think I've done an episode not about how to work, but about this API. Anyway, I will cover it later. For now, you can just see. Okay, when I check first, when I check if should yield or not, it will actually check how much time it costs for this for this task. If this one is smaller than 5 millisecond, this interval is 5 millisecond, then it return false. So do not yield. So I've give you the time slice of 5 millisecond. You need to do your work. If you are within that, your small task within that, then you don't yield. You continue working on the next step. But if you already cost more than 5 millisecond, then you should yield. Yeah, you should yield, and the scheduler will schedule it again if you are not accomplished, right? As we talked before. So that's it. So that's all about a scheduler, basically. So I've already summarized all the logic in one diagram. Let's cover it again. So ensure routes to schedule. Oh, I'm sorry. Schedule callback could be called in anywhere, but one of them is sure route scheduled. I've covered it like this. I've taken an example. When it is called, it will call schedule callback with priority, and callback is perform concurrent work on route, right? And in this, it will call the work loop concurrent, and this work will break if the should yield returns true, which checks the time, how much time it costs, and if it breaks and the update is not done, it will return this closure of itself as callback. So this is the callback, and after scheduled, it will request a process of these tasks, which will request callback of flush work, and in flush work, it will again use work loop and to run the task one by one, and it also checks the should yield. If not yield, it will just run a task again. If should yield, it will just break and give the method some time, and then request callback again. And when callback is actually this callback from us, if it is run, if it is interrupted, you will return the function as here the closure itself, and then it will update the task. If not, it means that task is done. Then the task will be popped, and this one is the main heap used to hold this task. It's just a priority queue. So yeah, that's basically all of the scheduler. I've talked about some topics that say I'll cover it later, but we don't have time for this episode. I will cover it later. One of them is the delay task in scheduler. Another one is how this priority is decided, right? We are more interested in how, this one. Based on events or something. Anyway, we'll cover it later. But this is the general idea of the scheduler. Whew, that's a lot of work. Yeah, I'm pretty proud of this episode, and I hope you enjoy it. And I personally learned a lot from this source code reading. Hope it helped. Maybe I should open a Discord or something. Anyway, thanks for your time. Bye bye.